Hi, this is Dr. G. We're going to go through the first 6 problems on version B of your first exam. There will be another video. There will be several other videos. I'm going to make these videos, try to make them short so they're not too long. So this one is problems 1 through 6 of version B of your exam. So let's start with problem 1. So problem 1 is an absolute value inequality. And in order to solve an absolute value inequality, we have to first isolate the absolute value expression before we can get rid of the absolute value symbols. So let's do that by adding or subtracting 3 from both sides. And what we're left with is 2 times the absolute value of x plus 3 is greater than or equal to 6. And now we got to get rid of that 2, so let's divide both sides by 2. And we're left with just the absolute value of 3 is greater than or equal to absolute value of x plus 3 is greater than or equal to 3. Great. So now the absolute value, we have to remember the absolute value of a number is the distance that number is from 0. So the number inside the absolute value here is x plus 3. So this inequality says that number, x plus 3, has to be at least 3 units away from 0. So there's 2 possibilities. Either the thing inside is negative, so it has to be less than or equal to negative 3, or the thing inside is positive, so it has to be greater than or equal to positive 3. So remember that the thing inside the absolute value symbol could be negative or it could be positive, so there's always 2 possibilities. All right. So now, and we have the word or in between, and why do we have to have or? Well, think about it kind of logically, right? So a number can't be both less than or equal to negative 3 and greater than or equal to positive 3 at the same time. So only one of those 2 things can be true at one time, so we have to use the word or. So now we can solve these 2 inequalities separately. So we're going to subtract 3 from both sides of the first one, and we get x is less than or equal to negative 6. Or the other one, we're going to subtract 3 from both sides of that one, and we get x is greater than or equal to 0. So all the solutions to the original absolute value inequality are numbers that are either the numbers that are less than or equal to negative 6 or the numbers that are greater than or equal to 0. Let's look at these solutions on the number line before we write it in interval notation. So I'm going to draw 3 different number lines. One number line is going to be all the numbers less than or equal to negative 6. Another number line is going to be all the numbers greater than or equal to 0. And then the final number line is the solution to the problem, which is all the numbers less than or equal to negative 6 or greater than or equal to 0. So the first number line, less than or equal to negative 6, those numbers, so we're going to include negative 6, so we got to use a solid dot at negative 6. And we have to include all the numbers less than negative 6. So we're going to draw an arrow going down, going to the left. Those are the numbers less than negative 6. The second one, greater than or equal to 0, we have to include the number 0, so a solid dot there. And the numbers greater than means the numbers to the right. So now the last inequality is the solution to the problem that we're solving. All the numbers that are either in the first set or in the second set. So that means we're going to combine the 2 sets. We're going to take all the numbers less than or equal to negative 6 and combine them with all the numbers greater than or equal to 0. So the word or means both sets together. We're going to combine the 2 sets. So now we're asked to write the answer in interval notation. So the first interval, the numbers less than or equal to negative 6, that is written as negative infinity up to negative 6. And then we want to combine that interval with the second interval. So we have to use the union symbol, which is like a big U. And then the other interval is from 0 to positive infinity. And notice a square bracket next to the negative 6 means we're including that number. And a square bracket next to 0 means we're including that number. We never use a square bracket next to infinity or negative infinity because those aren't numbers. Those are symbols that just mean keep going forever. All right. Problem number 2 is also an inequality, but it's a compound inequality. So number 1 was an absolute value inequality, which we turned into a compound inequality. A compound inequality is one that has the word or the word and. So an absolute value inequality is also a compound inequality. So let's look at number 2. Number 2 is a compound inequality, doesn't have an absolute value in it, but it does have the word and. So the word and means that both statements have to be true at the same time about the same number x. So this one is 3x minus 1 is less than 3 and negative 5x plus 3 is greater than negative 7. And x is the same number in both of those inequalities. So they have to be true at the same time about the same number. So what we do is we solve each of the inequalities separately, and we keep connecting them with the word and each time. So the first one, let's add 1 to both sides. The second one, I'm rewriting it as 3x less than 4 after I added 1 to both sides. The second one, I'm going to subtract 3 from both sides and rewrite that as negative 5x is greater than negative 10. And I'm connecting them with the word and. We have to keep using the word and because we're saying these two things are true at the same time about the same number x. So now the first one, to isolate x, we're going to divide both sides by 3, positive 3. And we get x is less than 4/3. The second one, we have to divide both sides by negative 5. Now remember, when you multiply or divide by a negative number, an inequality by a negative number, you have to reverse the inequality. So we have and x has to be less than positive 2. And notice that I reversed the inequality. It was greater than, and I switched it to less than because I divided by a negative number. So now, x is any number that is both less than 4/3 and less than 2. So let's draw 3 number lines again. And we're going to line up these number lines so that all the markings line up so we can visualize what's going on. So the first number line, we're going to graph all the numbers less than 4/3. The second one, we're going to graph all the numbers less than 2. And then the last one, we're going to graph all the numbers that happen to be in both of the previous sets. Okay? So the numbers that are both less than 4/3 and less than 2. And 4/3 is just a little bit bigger than 1. So that's why 4/3 on my number lines is between 1 and 2. And I've lined them up so I can kind of visualize what's going on. So the first one, x less than 4/3, means that we're not including 4/3 because x has to be strictly less than. So we're going to put an open circle at 4/3, and then our arrow is going to go to the left. In the second one, the same thing. We got to put an open circle at 2, and then the arrow going to the left. So now, in the third number line, we want to look at these two previous number lines and say, okay, which numbers are in both sets? In other words, where do the two sets overlap? And we can see visually, and I can draw a little dotted line. I can see visually that they're overlapping right here. So going from 4/3 and over to the left. Those are all the numbers that are in both sets. So I'm going to draw that on the third number line. So it's all the numbers strictly less than positive 4/3. So now to write this in interval notation, it's just one interval. So we're going to go from negative infinity up to 4/3, and we're not going to include 4/3, so we have a regular sort of round parenthesis around 4/3. So it's just a single interval. All right, let's look at number 3. So number 3 has 2 parts. So we're going to find the slope and the y-intercept of the line whose equation is negative x minus 3y equals negative 9. That's part A. And then in part B, we're going to graph the line. So to get the slope and y-intercept of this line, the easiest thing to do is to put the equation into slope-intercept form. Y equals mx plus b. So we just have to take the equation and isolate y. So let's add x to both sides first, and we're left with negative 3y equals x minus 9. Now let's divide both sides by negative 3, and we're left with y equals negative 1/3 x plus 3. Negative 1/3 x plus 3. So now it's in y equals mx plus b form. So m is negative 1/3, that's our slope, and b is positive 3. That's our y-coordinate of the y-intercept. Remember, the y-intercept is a point on the y-axis. And so the x-coordinate is 0, and the y-coordinate is this number b. So now we can answer the question. The slope is negative 1/3. The y-intercept is the point 0, positive 3. So it has to have 2 coordinates. The x-coordinate is 0. The y-coordinate is positive 3. So let's look at part B. Part B says sketch the graph. So we already have the y-intercept. We can plot that point, 0, 3. And to get the graph, we can use the slope to get a second point. Now, all we need are 2 points to sketch a line. So the slope is negative 1/3, so that means we can go down 1. Negative 1 means if negative 1 is in the numerator, we go down 1. And then positive 3 in the denominator means we go to the right 3 units. So I land here. I can get another point by going up 3, positive 1, and then to the left, up 1, and then to the left 3. So positive 1 over negative 3 would get us there. We don't really need 3 points, but I plotted 3 points just to make it easier to sketch my line. And then there's the line. So we start with the y-intercept and then use the slope to get another point and connect the dots. All right, let's look at problem 4. It says find the x and the y-intercepts of the line 2x minus y equals negative 2. So remember, to get the x-intercept, you set y equal to 0. To get the x-coordinate of the x-intercept, we plug in y equals 0. Because the x-intercept is a point on the x-axis, and all those points have y-coordinate 0. So we just plug in y equals 0, and we get 2x minus 0 equals negative 2, or 2x equals negative 2. Divide both sides by 2, and you get x equals negative 1. So that means our x-intercept is the point negative 1, 0. To get the y-intercept, remember we plug in x equals 0 to get the y-intercept. So when we do that, we get 2 times 0 minus y equals negative 2, or negative y equals negative 2. You can multiply both sides by negative 1, and you get y equals 2. So that means our y-intercept is the point 0, positive 2. All right, let's look at 5. This one, we have a given line And we're asked to find an equation of the line that's perpendicular to it that also contains the point 4, 3. So what we need to do to graph any line or to find an equation of any line, we need 2 bits of information. We either need 2 points or we need a single point and the slope. In this situation, we're given 1 point and we're told that the line is perpendicular to this other line. So what we can do is we can find the slope. And as long as we have a point and the slope, we can get the equation of the line. So to get the slope of the line that we're looking for, we need to find the slope of the given line. The given line is 3x minus 4y equals negative 6. So let's put that into slope-intercept form so we can get the slope of that line. So let's subtract 3x from both sides so we can isolate y. So we get negative 4y equals negative 3x minus 6. Now I just have to divide both sides by negative 4. And I get y is equal to positive 3/4 x, and then negative 6 over negative 4 can be reduced to positive 3/2. So now we can see that the slope of the given line is positive 3/4. So that means the slope of the line that we're looking for is negative 4/3. Remember, it has to be the opposite reciprocal if they're perpendicular. So I can write down the slope-intercept form of the line I'm looking for. I just don't know the intercept yet. I can write it as y equals negative 4/3 x plus some number b. Now all we have to do is find b and we're good. So to get b, we're going to use the point. The point 4, 3 has to lie on this line. So that means it has to, those two coordinates, x equals 4 and y equals 3, they have to satisfy this equation. So let's plug them in. Y is 3 and x is 4, so I'm plugging those in. And now I can solve this new equation for b. So I get 3 is equal to negative 16/3 plus b, adding 16/3 to both sides. 3 is really 9 over 3, so 9 over 3 plus 16 over 3 is 25 over 3. So I get b is equal to 25 over 3, and now my equation is just y equals negative 4/3 x plus 25/3. All right, let's move on to number 6. So number 6, we have an inequality with 2 variables. 3x plus y is greater than 3, and we're asked to graph it. So these problems require 2 steps. First, graphing the boundary line, and then the second step is shading one side of the boundary line. So we need to figure out which side of our line we're going to shade. So the boundary line is going to be the line that we get by just changing this inequality to an equality. So we get 3x plus y is equal to 3. Now, if we want to graph it, we should probably get it in slope-intercept form. So let's subtract 3x from both sides. So I get y is equal to negative 3x plus 3. So the slope is negative 3. The y-intercept is positive 3. And before we graph it, we have to decide if this is going to be a solid line or a dotted line. So we go back to the inequality and we see it's a strict inequality. So that means it's not greater than or equal to, it's a strict greater than. So that means that we're going to have a dotted line because we don't want to include the points that are actually on that line. So let's graph a dotted line with y-intercept 0, positive 3. And slope negative 3 means we're going to go down 3 and to the right 1, so we get that point there. Or we could go up 3 and to the left 1 and get that point there. And connecting the dots with a dotted line looks like this. So now we have to figure out which side of this dotted line we're going to shade in. And so we need a test point. So the easiest point to choose, it has to be a point that's not on the line you just graphed. And we can see that this line does not go through the point 0, 0, which is good because that's the easiest point to use. So let's use the point 0, 0, which is the origin. And what we have to do is plug this point into the original inequality to see if it satisfies. So plugging it into the inequality, we get 3 times 0 plus 0 is greater than 3. And I put a question mark over the greater than because we're asking the question, is this true? So is 0 greater than positive 3? The answer is no. So that point, 0, 0, is not going to be in the region that we're going to shade. So that means we're going to shade the opposite side of our line. So we're shading over there. If the answer, when we plugged in the point, the test point, if the answer were yes, then we would shade the side of the line that point was in. All right, this is the end of this video, so I'm going to make another video with questions 7 through 11, and then separate videos for the word problem. So there's a bunch of different videos for one exam.